Okay, the title of my experiment, as you can see, is Kills, Not Wheels. Ships have been used for many different purposes throughout the centuries. In 1918, the U.S. Navy transformed their passenger liner into one of the first aircraft carriers. These aircraft carriers were fairly good, except they swayed back and forth. So they created blige keels that were designed to minimize the amount of sway on an aircraft carrier, so that pilots could land safely. Um, During a trip, a ship often encounters heavy currents, winds, waves, and stuff like that. Um, when it moves back and forth, the pitch is the back and forth motion, and the roll is side to side motion. Blige keels are usually pieces of wood or steel that minimize the ship's roll and are placed underneath the ship. When the ship is in motion, water flows over the hull, and the keels produce a force that prevents the ship from rolling side to side. These keels are inexpensive because they don't consist of any moving parts. There are various kinds of blige keels. There's the ballast fin, blige, centerboard, and skeg keel up there. And these are all smooth pieces of wood or steel. The problem in my experiment is what kind of blige keel would minimize the oscillations of both the most, the inward, outward, or none of them, or none, no blige keels. My hypothesis was that the blige keels facing outward for both the 1 liter and 2 liter would minimize the oscillations of the boat to the maximum of 25 rocks, because the farther the blige keels are spread, the farther the waves are held back from hitting the boat. For my procedure, I obtained 6 1-liter bottles and 6 2-liter bottles. Some were used for blige keels and others were used just to make the boat itself. I cut rectangular holes with the long side going from the neck to the base. And on the inside of the boat, I poured rotor cement and then placed 23 marbles for the 1 liter and 53 marbles for the 2 liter. I waited for that to dry, and then I had an opening already set for a dowel, a 12-inch dowel. Then, after all that, I finished that, then I drew a black line across the side of the ship so I can mark how far I'm going to bend my wave. And then I filled the bathtub with 20 centimeters of tap water, and for the wood block test, I used the ruler that I had to measure the amount of distance, so it's always constant. And for the first dowel test, I tilted the boat by the dowel to that marked point that I had, and then I let it go. I waited so the bouncing back from the tub wall to see, so when it was like calm a little bit, it would still move, so I counted from there. And then the 1 minute 30 seconds started when I let go. I recorded the amount of oscillations after that 1 minute 30 seconds. For the wood block, I placed my wood block was 16 centimeters by 13 and a half. I tapped it at the beginning and then tapped it again in the 45-second point, and then I tested 10 1 minute and 30 second periods of each boat, and took the average of the 10 throughout the trial. For my entire experiment, I had 6 different boats, so 30 tests each. The boat with the blige keels facing outward averaged between 20 and 23 oscillations, which was proven to be the best. The inward facing blige keel went through the center, straight to the center, came in second because the oscillations probably hit it before it could actually do some work. And then the blige keels facing outward had the lowest compared to all of them, and then the one without had between 44 to 45 average, which was the most. For the 1 liter bottles, the results were almost the same, except a variation in numbers. The block test seemed to go higher, probably because the boat is smaller and it picks up more waves quickly. for my conclusion of my experiment, my hypothesis was indeed correct, that the glide kills facing outward on the 1 liter and 2 liter bottles would minimize the oscillations of a boat to the maximum of 25 oscillations. A practical application for this experiment would be for boats used for aircraft landing strips or ships that travel routine turbulent routes across oceans, and it would steady it better so pilots could land smoother.